Hello, good afternoon. My name is Professor Awad, and welcome to NetW 203 or 202, depending on which class you're taking. Today, I'd like to cover and go over Chapter 1 with you. So I'll go over it, explain what the whole chapter is all about, and this is not really um, to exempt you from reading the book. So it's still very important for you to read the book. And if you go over the book and you still have any information, any questions, please don't forget to ask. And also, what I'm going to do, especially for the Net W203 students, I am going to ask several questions in there, and I want you to answer them. Write the answers down, and you are going to submit those as homework. Okay? So just pay attention, and I'll tell you which questions they are as we move along the lecture, and in fact I'll answer them as well. So this way you don't. I just want to make sure that you went over the and has listened and paid attention to the lecture as we go along. All right, again, welcome. This is going to be an exciting chapter. In fact, 203 is really the beginning of the Cisco Academy. So we will discuss that in class. When you finish up 203, 205, 207, and 209, you should be prepared to do your CCNA. The first two actually get you set up for the CCENT. Okay, but we'll discuss that maybe in class. So let's begin with chapter 1. Here are the objectives for chapter 1. After accomplishing everything that we hopefully do today, we'll explain how multiple networks work, how the topologies, what they are. You'll know the difference between a router and a switch, maybe. Where are we going with the networking? We'll get into what's cloud computing, virtualization, why all of that stuff is so important for us. So it's a pretty important chapter because it covers everything that we're going over this whole semester. It's just information, really not a lot of details. Later on, we'll get into the actual details. So here's the chapter how it breaks into what is globally connected. So we'll describe, you probably a lot of the stuff that you have in here. Some of it you already know about, so just hang in there. But it's just going over to get you excited about networking, how everything is connected together. We'll describe what LANs and WANs are and how is that different than the internet? What is the internet and how does it work? Um, and what's the changing environment and where are we going from here? And what's the next big thing maybe? Well, nobody knows, but what is the trend? That's what we're going to be looking for, really. All right, so where are we going? What's the trend? In the old days, in the early 1990s, networking was a big thing. All computers wanted to be networks. You had a system administrators, you had file servers, and from Microsoft to Novell, they created their own servers, and it was a big, big thing, and it started to grow. In 2 years, I remember in the mid 1990s, AOL grew over 30 million users with the dial-up internet, and it started to grow like crazy. And then we were running out of IP addresses. And by 1998, um, we decided, well, the IETF, the Internet Engineering Task Force, got together and got all the big heads together, and they came up with IP version 6, which expanded the IP addressing and took care of all the issues that IP version 4 had. And mainly that's what we are going to be in the next 5 to 10 years from now. IPv6 we'll talk over, but we'll get to IPv6 maybe down the road. Everything right now, everybody wants to bring in their own, you know, bring in your own device into the network. We'll set it up so this way companies now don't have to buy equipment for their users. You can bring in your own equipment. They'll set up the software on it, and then and it's the security is really very tight, so there it's not a problem at all. You can do whatever you want with the device. So this saves companies a lot of money. They don't have to, buy the equipment or take care of it. You just bring in your iPad, laptops, whatever device that you need to, and you can do some of your work. Internet of things are moving very quickly. Everything now is on the internet. From your car, your home is connected. Obviously, your iPads, iTouches, your phones, you name it. You know where everybody is located anywhere. You can have meetings now online. You can find your devices no matter where they are. Now, things are moving very quickly, and we're moving into something that's called the Internet of Everything. Everything is going to be on the internet from your, never mind the social medias and everything in terms of your car. Tesla has a car now that can be updated remotely. Everything. There's nothing in there. You don't change your oil. You don't even have to take it to the shop. They'll let you know wirelessly what's wrong with your car, and if there is anything wrong. Obviously that poses a lot of security issues because if somebody can hack into your car and disable your braking system, it's going to be a big issue. But that's things to worry about down the road. We'll get there, and hopefully, I don't know, there'll be a solution for that. All right. Anyway, so everything is going to be on the internet, and everything is going to be connected. So therefore, you need experts that's going to make sure that things that get connected are scalable, easy to expand, they are secured, easy, you know, make sure that it's not easy to be broken into in terms of data or denial of services. You want to be able, you always want it to be connected no matter where you are. Excuse me. And you always want to be also, it's easy to maintain and upgrade. So, in terms of the IT, it's growing extremely fast. I just heard recently, you know, that Amazon is trying to hire over 16,000 ITs, and um, they can't find enough help. PayPal is hiring a couple of hundreds as well. This is 2014, and then during the holidays, but it's still, even the Department of Labor thinks that projects that IT, computer specialization, is going to grow over 22% for the next 10 years. So that's good news, and the economy is turning. All right, but remember, things keeps, you are in the field of technology, and things are going to change. So you got to be adaptable. You got to be able to learn all the time. So by the time you graduate, it'll just be the very beginning. Here's an example, for example. Instead of having corporates or companies go out and meet in different areas, now what they can do is Cisco can go in, take a room in your company, set up maybe three HD TVs where you can have a conference. It's almost live. You have a voice activated camera. So if anyone wants to speak, that camera will tilt towards them. You can share data with each other. And it's really a wonderful thing to have because now you don't even have to travel anymore. And you can always have a conference at any time, almost instantaneously. And of course, but you need high bandwidth for this. You can't just do it with a dial-up or something. You need at least 100 megabit throughput to achieve something similar to that. All right, so how does it impact our lives, networking? So how we learn, of course, now there's a lot of classes online. Look what we're doing right now, how we communicate. Everybody now texts, in fact, doesn't even make phone calls anymore. When you go to work, you can, if you get sick or you had the flu or anything, you can stay home and do your work from home. You don't even have to you don't have to try to drive to work anymore. And of course, online play. Kids now, all they do is they're stuck on their TV, and they no more TVs. They actually go in and get online to play all their games. All right, so you go from small home networks, small offices, bit large or medium networks, and the whole internet. Everybody's connected. So you go from your home or your office, or if you work in a mid to large corporate, this whole thing will be network, or you can have the whole world. All of these large networks are interconnected together. That's really what this is like, something to the internet. You could have this on the public internet or privately. We'll discuss many of that as we go along. All right, so now let's get into some of the basics. A network means when you have devices that are connected together to share data. And what I mean by data right now, it could be anything. It could be an HTTP file. It could be telnetting to another device. It could be sending an email, voice. Right now, what I mean by that is um, data means any of those services. For example, um, you have an email client. He can send, he is the file server, a browser client. He can access the web server. The email server sends his email to the email server, and so on. This, this file access client can send his data to the file server. This is a switch. A switch is a device that interconnects hosts inside a local area network, a LAN. So when you send a frame or data to a switch, the switch will look at that data, find out where that data is supposed to go. In other words, finds out which port the destination is located at, and then that data is switched directly to that device. So the main device that interconnect hosts inside a LAN is a switch. So here's question number one. What is the main device that connect hosts inside a LAN? And the answer is the switch. Servers, devices, instead of talking to each other, they need to go to a server, or they can communicate with each other. But if they need a service, for example, if they want to send email, they send it to the email server. If they want a web, if it's a web server, this will have HTML pages that can service all the clients. Or it could be an application server, or a file server, or a print server. So these are called workstations or clients. They requests services from the file server, and the file server will give them what they need. You have a lot more control when you put everything on a file server. It's easy to back up, and it's easy to secure, and you have control of what these clients can and cannot access. Now, by the way, we eliminate this file server and everything. This file server is in the cloud. In the cloud means somebody has it someplace over the internet, a company, and you just send your data up there. And therefore, you don't need to maintain a server on site. These third-party company will take care of upgrading, maintaining, and securing your data. Now, of course, the issue there with cloud computing is that security. I mean, if your data is sensitive, that's going to be always an issue. All right, but also we'll get to that, down the road. All right, peer-to-peer connections. Peer-to-peer connection meaning having two devices that are directly connected to each other. Why do you want to do that? Because it's the least expensive way to do it, and you want to share data. A lot of people don't necessarily wire themselves this way. They do this wirelessly. So if you have a couple of computers at home and a printer, you could do peer-to-peer, actually, a network. This is hardly ever done anymore, but it's doable. So you can connect two devices together, create a folder where you can, you know, put in all the data that you want in the folder and share it. The good thing about it, again, it's easy to set up, not complex at all. In fact, all Windows based from the old XP and even prior to that allows you to set up a peer-to-peer connection without it, no additional software or anything like that. The disadvantage, there is no centralized really administration. You can't really administer these, and these two guys have the same pretty much power. I don't know what this guy is doing and what he or cannot access. So it's very difficult to manage. This is typically done for home use, not in a corporate environment. You want a client server, like the one we just discussed before. Okay. All right. Now moving on to LANs and WANs and what they are. Okay. A local area network, a LAN, means that our devices that are connected in one broadcast domain. And for example, if you send your data, if you are in a building and you're sending your data and this switch passes your data around, that means you are inside your local area network. If you need to go outside, then you send your data to a router. Now, here's what we're going to do. An analogy to a router. A router is like a post office in your area. So, and the switch is like the mail guy inside the building. So if you give your data to the mail guy, the switch, that mail guy knows where everybody is located, their room, and he just sends that data to whoever you want to send the data to. Now, if you have a package that needs to go outside of your building to go somewhere else, so you take that package and you send it to the post office. Post office are the routers. So post offices, they look at the IP addresses, which is like the zip code, to where you're going. And they pass it from one router to another, from one post office to another, till it gets to the post office of where you are located, passes it on to the mail guy, and then the mail guy will get you in there. So we'll get you your package. So routers are like post offices. They interconnect LANs, this LAN with this LAN. The connection of two LANs that are in different geographic areas is called a WAN. So question number 2, what is the WAN? A WAN is the interconnection of two LANs that are in different geographic areas. Okay. Media is where data travels. You know, the media in this case, it could be a fiber optic cable, it could be a copper wire, or it could be the RF signal, the radio frequency signal, a wireless signal. Services means what are you transferring? What are you sending? Are you sending a web page? Are you sending an email? Are you downloading or uploading a file? Okay. So devices are the devices that are going to send the data. The media is the where data travel, and services is what you're trying to send, the application that you are using. All right, here are some examples of end devices. Computers, of course, are that's workstations, laptops, file servers, web servers. You have network printers, voice over IP phones. All of those, they generate data and they send out, um, and so on. Okay. The devices that interconnect, that receive data from workstations are switches, wireless access points, routers, firewalls. We'll discuss all of those different, what a firewall is. And a wireless access point is to interconnect wireless devices to a wired LAN. Firewalls are like security guards, and they have a list to check if you are allowed or not allowed to go into the network. That's all it does. We'll discuss a little bit more of that down the road. All right, here's some different types of media. I mentioned that just a little bit earlier. Here's some copper wires, the unshielded twisted pair cable, fiber optic wires and the wireless devices. You know, the best way to go, of course, is fiber because it allows the highest bandwidth, longest distance, and the most secure, the least expensive way, and with somewhat better speed. Although nowadays with the 802.1d network, AD network, gives you a pretty good speed. The copper wires is still there because most corporate buildings are wired with copper wires. So they're pretty the least expensive way, and they're pretty good. They can give you up to 100, 1,000 megabits per second, gigabit Ethernet with the copper wires. Now, which one do you want to go with? Of course, you want to go with fiber, but that's a little bit more costly than the copper, of course. Now, it all depends on who your client is and what do they want and how much money they're going to spend. Is security an issue? And all of that comes into play. And where you are going to lay out the wires, um, that all comes into play. We're going to have one full chapter discussing network media and how it operates and the use of it, and get into a little bit more details about the network media later on. All right, network representation. So throughout the book, this is the workstations, laptops, and these are, and as you can see, a LAN switch has the 4 arrows on the top. The router is a circle with an X in it. This is the connection of two devices that are connected wirelessly together. This is an Ethernet connection typically, and this is where you have two routers connected. That zigzag line indicates that you really don't know what devices you go through to get to the other device. So this is a WAN media connection. Okay. All right, here's a typical physical topology. Physical topology means the physical connection of the devices. How do you physically connect them together? So if you were ever hired as an intern or on your first day job, you should know where every device connects to. Do they connect to a hub, a switch, and and that switch or hub, is it connect to where, on which router, which interface? And you should trace these wires. So you'll know in case you need to troubleshoot, it is good to know ahead of time who is connected to what. So the physical topology means how devices are physically together. Logical topology means software-wise, which area are you in? Like, what is your IP address? IP address is something similar to a zip code. Now, the thing with the internet, if you are on the same zip code as somebody else, that means you can communicate with each other. That means you're in the same subnet, regardless of your physical connection. So that's what's logical connection. Logical connection means your IP configuration, your IP address. You should also know that because if you are, for example, if you and the printer that you're trying to print to are not in the same zip code, subnet, in other words, you won't be able to print. So you should write all of that down. Now, when you go into a company, they should have these written out. They'll have the layout and they'll tell you that this subnet, typically the group in one room will have its own zip code, IP address, a subnet, for example, and another group will have its own subnet and so on. So, and they'll number them so you'll know exactly who has what. So in case you need to add devices, take out devices, which is the DHCP pool that you need to configure later on. So all of that will be easier to work with. So you should study all of that, the layouts of the physical and the logical topology. Okay. All right, let's move on. All right, we categorize networks into two networks, two major ones, the LAN and the WAN. And like I've discussed earlier, the LAN is, think of it, you are in one building, the interconnection of devices together. If you own all the devices plus the media that connects these devices, then you are in a LAN. A WAN means, again, is the interconnection of two LANs, but they have to be far away from each other in different geographic area. Think of it this way. If you have to pay a service provider to connect you in one location to another location, or even you have to get on the internet using a VPN, then that's a WAN. That's considered a WAN. But if you have two buildings that you can run a wire between them, that's not a WAN. That's still your own local area network. Now, there's something called metropolitan area network, which is, having buildings, buildings for corporate in a city limit, and that's called a metropolitan area. There are some protocols that can give you pretty high bandwidth if you are within a city limit. Wireless LANs are typically either at home or even in a corporate environment where you want to connect um, wireless devices to a wired network. Storage area network. Now you have companies that store your data to back up your data just in case something goes wrong offline. And these are also a fast growing field in networking where most companies now don't no longer want to back up their data. That's part of, think of it this way, part of cloud computing. You store your data off-site, so in case something goes wrong, you'll have access to them. And you can, banks do that. Everybody does that actually right now. There's no reason to have anything on site anymore. And it's growing very, very fast. Everybody's pushing it out. All right, back to a local area network. So again, LAN is the interconnection of devices together, directly connected. So a switch is the device that interconnect all of these devices inside a local area network. And again, a WAN is the interconnection of these two LANs together. Routers allow that to happen. Like I said earlier, the routers are the devices that interconnect the LANs together, like similar to post offices, right? The internet is nothing but a big, huge public WAN. So it stands for internetworking. So you have a whole bunch of routers. Think of it this way, post offices, and they are out there. They interconnect all these LANs together. Now, these are really for the public for free. You can use these routers, and these have very, very fast connections. So if you send data to them, they move your data very, very quickly, pretty much for free. You just need an IP address to interconnect. So for example, if you want a World Wide Web server, you just put a World Wide Web server, give it a public IP address, and let's say you send your data to the service provider. Your service provider is the one that usually connects you to the internet. So he takes care of all of that stuff, putting you on the internet, bring your data back in. So you just have to pay for the connection to that service provider switch. So typically when you pay for 100 megabits connection, you're really paying for that, what they call the local loop, the connection between you and your service provider. Once you send your data to your service provider, imagine this, your service provider takes your data and throws you on the internet, and you go on your merry way. And you go pretty fast. Obviously, when you are on the public internet, there's a lot of bad people there. There's a lot of viruses, and it's not regulated. So you got to make sure that the data that you are sending is safe, encrypted, and so you can get there as quickly as possible. All right. And actually, there's another internet too they're working on for much, much even faster speed because they realize that the whole world is going to be connected. And of course, that raises cybersecurity. Cybersecurity is going to be a huge issue in the coming years. So that's maybe something you may be thinking about, the field that you might want to get into. All right, so a couple of terminologies. I don't know how much we're going to use this, but if you hear the word intranet with an A, that means you're talking about network inside your company, computers that are interconnected inside, and only for the employees inside the company. That's an intranet. When you talk about extranet, that means your people plus your customers. You're allowing several customers, suppliers to connect to your LAN. So you and them are called, these people outside your LAN, like your suppliers or customers, are called the extranet. The internet is when the whole world is trying to connect to you, or you're connected to the whole world, not just to your suppliers or customers. All right, so how do you connect to the internet? Well, you may use DSL, cable, cellular connections, whatever it is, or dial up. Like I said to you before, you take your data, you send it to your DSL or cable modem, and your cable modem takes your data and sends it to a switch at the central office of your internet service provider, and the internet service provider takes your data and throws you on the internet. Now, the ISP is not responsible for what happens to you when you go out there, but he may provide some, antivirus programs for you, maybe spam filtering, you know, for email spams, firewalls. You have to set that at home too, as well, just in case. So you got to provide all that security because all that garbage can be coming and into your LAN directly through the service provider. So you got to be very, very careful. They are just responsible for giving you internet connection and taking the data and sending it back to you. So you're really paying for, like I said to you earlier, if you're paying, for a 100 megabit connection, a T1 line, it's the connection between you and the service provider. This is called the last mile or the local loop. So question number 3, what is the local loop or the last mile? The local loop is the connection between the customer and the service provider. Okay, that's it. All right, so you can ask for any of these connections, dedicated line like a T1 line or Metro Ethernet or DSL. All right, so converging networks. In the old days, we used to have different services for, let's look at this first, the converged network. If you wanted telephone service, you had to call a telephone company. If you wanted video, you have to call a separate video company for that. And if you wanted data, you would have called, for example, AOL. Now they converged everything onto one media. In other words, you can have voice, video, and data coming into your coaxial or fiber optic cable. It's much cheaper for the companies to do that, and therefore, eventually, supposedly, it's less expensive for you as well. So that's what a converged network is when you put all the services on one line. That's why you hear everything over IP, video over IP, voice over IP, data over IP, everything will be over IP, you name it. All right, so that also creates an issue. How do you separate those different messages? And you have to have switches that will allow you to do that. All right, so you learn all of that down the road, by the way. Okay. Devices, when they communicate, they have protocols on how to communicate, standards, when to speak, when to be quiet, so the other one can process the data and so on. So they allow themselves and they set themselves for communications. But also, again, we'll get into details on how they do that. They just don't send the data out and eventually it gets to the other device. There's a standard on how they communicate. Standards means that's what the word protocol means, a standard that you have to adhere to. All right, so planning for the future, making sure that where your company is right now and is it scalable? Are you going to adapt to the new technologies that they have? Are you going to do video conferencing? Um, do you want your employees to be connected 24/7 worldwide? It all depends on who your client is. Do you want to do online classes if you are a university, for example? Do you want to play games online from now on? This is also a big growing field for the gaming companies that are out there. So where are we going to go from now? I don't know. We'll see. It all depends, but it doesn't really matter. If you're really into this stuff, it's going to be a really big field to get into. All right, supporting the network. Now, once you have a network, your main job is going to be to make sure that all users have have connection to whatever they want to. The availability to have connection to their resources. So, first thing that you want to do is you want to make sure you have some fault tolerance, have some backups, maybe an additional links between two switches, a backup server just in case the data fails, even down to hard drives or mice if you need them on site. You don't want if somebody comes in and says, I can't connect to the printer. That's unacceptable. You got to make sure that there's another printer that data can be routed to in case that printer went out. Even if just paper, there's no more paper, you got to make sure that all of that is taken care of. Okay? All right, scalability. Almost every company that I know needs to be scalable, mean easy to expand without any issues. Now, if you design your LAN the way we're going to show you how to do that later on, it'll be it'll be scalable. It will be very secure and easy to maintain as well. If your network is not scalable, it's going to be a big issue because now if you need another LAN or add more users, it's going to create traffic and then it'll be a big headache for you and for your company, of course. Quality of service. You want to make sure also some data needs to have priority than others. For example, you want your switches and routers be able to recognize that the data that's coming in is a voice and that voice packets have to be sent directly to the host without any delay. So therefore, those routers and switches that are able to set priorities to the data that is coming in or out have a quality of service feature in them. And of course, you have to have your data secured. Security is the most important thing. If you can be one of the most intelligent, smartest, biggest network engineer, and you can set up networks in a flash, but don't know how to secure them, you know, it's a big problem, of course. Somebody can come in and bring down your network in minutes. What's the use? And the most important part of security is physical security. So, talking about cybersecurity, firewalls, IPSs, and all these different terminologies, and you can spend years how to set up firewalls or VPNs or anything like that, and then someone has access to your devices, then it's all gone. It's useless. So some people take that for granted. But security is a big issue. But again, what it comes down to all of this, even all for fault tolerance, scalability, QoS, or security, comes down to users being able to access or have the ability to access to their resources whenever they want to. So when they come into work, they want to be connected and they want to reach whoever they want to reach, whatever they want to reach anytime. So that's your job. All right. So for tolerances in a switch networks, you can have, an extra switch. So in case this link breaks, you can reroute your data somewhere else. And packet switching, the good thing about packet switching is you can take different routes. This is like you want to go home. This is your home. And you're traveling and you always take this road to get home. These are like cities that you go through. So if this road is blocked, then you are rerouted. Imagine there is no fault tolerance, then you get stuck at work forever, which means there is no other way but to go this way. And if anything goes wrong, if the city shuts down, for example, or if the road is closed, what are you going to do? You are always rerouted that way. All right. Scalable networks means you want to be able to easily expand. And that's how the internet and that's how we were we were able to expand the internet worldwide. You go from your local ISP to a second tier ISP to the first tier ISP before you are placed on the internet itself. Okay? So your first connection is to your local ISP, whoever that local ISP is. But eventually, you really, this is what the cloud is right here, pretty much. Anything, once you leave your service, once you get to your service provider, even your service provider, your local ISP is considered to be the cloud because you don't know where your data goes through to get to this guy home, for example, and so on. Okay, planning for QoS, you need to understand who is going to have priority data-wise. Can it be time-stamped communications, depending on your time, increase priority for services like telephony or video distribution? So somebody that needs to be there as quickly as possible. For example, this is like, think of it this way. If you are on a highway and you're traveling and there's an ambulance behind you, and if there is no traffic, then everybody is, okay, they'll be going at the same speed and the ambulance doesn't turn the siren on. But if there is traffic, you move over and you let the ambulance go because, you know, that means those roads have quality of service. They're going to allow voice over IP packets, the ambulance to go through. Okay, and things like that. Something that is very, very important. If you have certain data, for example, that needs to be sent out to your customer, so you'll let that go first before anyone else is. Before you let your employees, for example, send emails or anything like that. So you can configure all of that on your router. Say if you see, a packet coming from the CEO, send that out first. Or anything that's coming to the CEO computer, bring that in as quickly as possible before anyone else. That's high importance to the organization. So you can set all of that. So routers and switches should be able to can be configured to set priorities for which packets should go in and out of your network. Okay, so when it comes to network security, setting up a firewall, like having a security guard in the front building, looking at all the data that's coming in and out. It could be anything from you encrypting your data, having an access policy, who can come in and not coming into your network. Identity theft is one of the biggest things. Over $2 billion a year are lost is caused by identity theft. And the biggest thing is really social engineering. Most of these coming from the internet. They send you these fraud um, emails, for example, telling you send $1 million. Um, I got one email one time that I was told that I bought a $2,000 LCD TV on eBay, and if you don't log into your account, you're going to be in trouble. Just click on this link to verify it. Of course, you want to click on that link. They wanted me to click on that link so I can type in my account information, and that's all they wanted, so they can get it. So you got to be very, very aware. User awareness is the most important thing when it comes to identity theft. Don't give your social security to anyone unless it's really unless it's the IRS or somebody that is very, very, or you're going to get arrested for. Don't give it to your doctors or anything like, because that's how they get you. You got your name, they got your birthday, and they got your social security number. So make sure whoever you're giving your social security number to, you know who they are, and they're going to protect it. Anyway, security is always going to be a big, big issue. You can have your PhD in security itself. All right, the new trends that are happening today. Bring your own devices. Now, companies, they love this because they don't have to buy any equipment for their employees. All they're going to ask them to bring your own laptop and we'll configure it so you can have connection to our network. and then you can do whatever you want with your own device. Okay. Online collaboration, you can get a lot of work done online, and you don't have to do everything, process everything that you want right here. Even with Google, or even with a lot of forums that are out there, they can help you do anything that you want. Video, sending out videos, streaming videos. Netflix is a big, huge, and all the video content is being delivered now by video. And that's probably another trend that is moving. No, everything is going to be on the internet. And those those broadband companies, from Cablevisions to Verizons, they may have issues in the future that deliver the content. All right. Anyway, cloud computing, like we discussed earlier, cloud computing is when you no longer need to have a server on site. You can put that server somewhere. A company can take care of all of that for you, and you just send your data up there, and they upgrade it, they maintain it, they secure it for you, and you always have connection. There is no need to hire somebody on site to take care of all of that stuff for you. But like I said to you, security will always be an issue. All right. So there is your bring your own device. So maybe when you get out of here, get out of school, that's something that you are going to deal with. So you should be familiar on how to configure laptops, iPhones, iPads, you name it. How to set it up, set them up and secure them. Secure your data that's in there on those. Because remember, your employee will have that device and they can do whatever they want with it, and they may share it with others. So whatever you put on there has to be secured. Okay, so you can collaborate with other people online to find solutions. I almost, before I go anywhere, I check online to see if, even to fix my car, to fix my PC, or to purchase anything online. You always can check it out and see what you could do. And of course, here we're talking about companies. They can collaborate, do video conferencing, IP phone connections, you know, messaging, emailing, you name it. All of that can be very easily done without having to travel. Video communications, like I told you earlier, that's growing like crazy. And HBO and CBS are now offering all of their content online for $5 a month. Now, I mean, are we going to do that and no longer, have to go in and purchase hundreds or thousands of channels from Verizon, for example, and pay the whatever $100 a month? Are they going to, pick and choose? But that might be costly too, by the way. If you pick a few channels, that brings it up to $30, $40 a month. I don't know how that's going to work, but we'll see about that. We'll see, the trend, or is Netflix is taking over. And there's a lot of free videos online that you probably already know. You probably don't even need all of these channels anyway. Okay, so when it comes to cloud computing, and the potential benefits of that is the organizational flexibility. Really, what it comes down to, it's going to reduce the cost. Not having a server online on campus, and not having the IT staff to take care of all of that stuff, it reduces the cost. And not having to worry about upgrading or backing up the data. As long as your data is not sensitive, put it in the cloud. Let someone else take care of it. For DeVry, we have when we take the attendance, we use Salesforce.com. We put all of that information up in the cloud. We use your name and just your DSI, your D number. There's nothing sensitive about that. You just were present or not present, and we just save it up. Why have a server on site to take care of that? All right. Data centers. So data centers are like backing up your data, which is very, very important. Okay, in case something goes wrong. In the old days, we used to have a backup servers on, and we have to train somebody on how to back up and restore the data. Now it's all done remotely with fast connections. No more, in the old days, they used to have backup tape drives stored at a different on different on different campuses and different areas, and you have to run around to bring up those backup tapes. Oh, God, I remember all of that stuff. But now, just from your office, you can bring down and upload anything that you want to data centers. Now, these computers, these servers are huge. EMC and virtualization is a big, big thing. So you may be working for big companies like EMC or IBM is trying nowadays to move and even Microsoft into the cloud computing. So these servers have to have the software and the hardware to support, high speed or high volume of data. Okay. So trends at home. Your car is going to be connected. I think we mentioned that earlier. Your phone, your home, everything. You're going to know where everything is located. Again, that poses a big security issue. If somebody can hack into any of these now, it'll give you a big, huge headache. Powerline networking. For example, if you don't want to wire your home, you can use the electrical wire connection in your home to send data. But the only thing you need to remember is the plug that you use and the other plug that you use in another room to you want to use that wire, they have to be on the same circuit breaker. If you are not on the same circuit breaker, that's the trick. You can't connect. So you can send data. Here's your wireless. You can send data through here on the wire and get uh, an extender right here that you can connect it to your TV. I mean, to be honest with you, I don't bother doing that. I'll try to run a wire in worst case scenario and bring it right next to the TV if I had to. Or even you can use your power line connection. The technology is out there that allows you to do that. I haven't used it, to be honest with you. Wireless is really, everybody almost has that. Everybody is, why bother running wire all over the home where you can have your devices, from your phone to iPads to your laptops, even to your TV, you can connect wirelessly. You just have to place your wireless router in a very strategic area, typically in the middle. And if you have 802.11n or even AB, as long as you are within 150 feet, you should be okay. And no obstacles. Don't hide your wireless router behind your TV. Put it in an area where the signal can be radiated out easily without any issues. Now, of course, threats to the network, it could be internal from inside your LAN. Your employees could be having viruses, bringing in their own USB drives with viruses on them, or even their own devices, or an attack from outside that they can go through the firewall. So you have to be able to protect against both of these threats. Okay, so what are threats? Viruses, wounds, Trojan horses. Viruses can, of course, you probably know what a virus is. A virus is a program that attaches itself to a legitimate program and uh, and does bad things to your computer. It can screw up all the files, even now kill the operating system. You know, making you lose your data. Worms are nothing but viruses, but they propagate from one computer to another if they are networked. Trojan horses are files that go onto your computer and they sit dormant. They don't do anything for a while till an event or a time expires and they kick in. Spywares and adwares. Spywares, they watch what you're doing, you know, and mainly they spy out what you're doing and trying to bring an ad for you to figure out what you're looking for. what you're trying to buy, which websites you go to, so they can sell you something. That's what it really comes down to. 0-day attacks, that's like somebody, or 0-hour attacks. Somebody makes up a virus right this moment, and therefore there is no really, there is no solution for it. There's no antivirus program that can detect it. So how do you take care of that? There are ways of, as long as you are setting certain rules of not allowing everybody to come into your network, you can pretty much prevent the 0-day attacks. But if you're not, then you are going to be vulnerable. Hacker attacks, somebody that really can get your password or get your wireless keys that you are using and trying to break into your network. Denial of service attack. Somebody can, for example, attack your router, wireless router, keep sending it requests, or your server, and therefore the server or the access point cannot service anyone else because it's trying to respond to those massive amount of requests. Okay, and of course, like data interception and theft. But the way to protect against that is through encryption. Identity theft, mainly you got fooled. Somebody got your password or your identity and is you, or you were not careful, just you know putting your password or your username out there for anyone to see. So you got to be very careful. All right. So how do we protect against all of that? Antivirus programs, of course, setting up a firewall, not to allow anybody in or out. Uh, firewalls, they use something called access control list. You know, who is permitted to have access into your network and who is denied. IPSs are devices that look for patterns of attacks. They're called signatures and try to stop those attacks from happening. IPS are really designed to stop denial of service attacks. VPNs are used to set up or encrypt your data when you want to connect from one network to another network over the internet. Now, because the internet is unregulated and unsecured, you want to encrypt your data and tunnel it. That's what a VPN is. All right, so we discussed collaborations, data centers with virtualization. So you don't have, you can have a virtual machine now on your regular desktop. So you can have, Windows and on an Apple computer, for example. You don't have to have two different computers. So you'll do some of that in different classes. Borderless network, that means everybody will be connected together. So that's where we're going with the Cisco architectures. They want to connect everybody. All of that are going to merge eventually together. All right. So where we are this is we're coming towards the end of this chapter. You are going down here at the entry level. When you finish the first two classes, NetW 203 and 205, well, for those who are doing it online, the first two classes, 202 and 204, you're going to do your CCENT, the entry level. If you do the next two classes, 205 and 207, I'm sorry, 207 and 209, then you're going to be at the CCNA, the Cisco Certified Network Associate level. And then three more exams, three more classes, get you to the CCNP. Then you can go up to the expert and to the architect. When you are an architect, you pretty much know everything that Cisco does and all of their devices. And, you know, having a certificate is just as important in the networking field, is just as important as your degree. CCNAs or certifications such as these will get you in, will get you to the hands-on, but your degree will ultimately get you up going up the ladder. You need your degree if you need to move up. Your certification is good because it shows that you know what you're doing and what you're talking about and gets you in. In terms of salaries, it all depends on how much you know or who you know too, and and what degree do you have and what knowledge do you have. But having a CCNA is very, very important. So that's something that you should be looking for after you finish these 2 or 4 courses that we have here. All right. All right. I know I didn't ask a lot of questions, but I will see you on my chapter 2, and we'll talk about that next time we meet. All right. All right. Good night, and take care, guys.